talking about a relatively cool water fish now, the wreckfish. It's a species that it's found again throughout the world, but in Europe, the majority of the stocks that we had were in the northern part of Spain, in Galicia, and Blanca will give us a presentation as the species leader.
We are talking about the wreckfish objectives and progress, and finding new emerging species for the DIVERSIFY project. We find that the wreckfish apply different criteria. Economic criteria, economical potential, cover an European geographic area, large finfish market, high market price, high demanding from consumers, and new value added products. Regarding biologic criteria, biologic potential is fast growing, is large size, late reproductive maturation, easy manipulation in captivity, extended pelagic juvenile phase, and respecting with the criteria sustainable, its nutritional value, the limited fisheries landing, the possibility of repopulation, stimulate different aquaculture systems, like as cages, ponds, extensive recirculation, etc. And is acclimatized easily to captivity, made the wreckfish a species very interesting for the aquaculture. And what we didn't know, sorry, excuse me. We know they acclimatize easily in captivity, the low mortalities of the species in captivity, the species accepts inert food easily, is high growth rate, is late maturation. Some knows about the reproduction cycle and the existence of wild specimens in captivity. With that, we don't know. We don't know the reproduction control, the spawning preferences, the methods of spawning induction, lack of larval rearing, and the scarcity of wild broodstocks, and the nutritional value and preference. For this, our objectives in the DIVERSIFY project were reproduction, nutrition, and larval husbandry. Regarding reproduction, 4 tags we proposed. One was increase the availability of wreckfish broodstocks in captivity. Another one described to the reproductive cycle in captivity. Another third one developed spawning induction procedures. And the last developed a CASA for evaluation of wreckfish sperm. Regarding nutrition, 2 tasks we proposed. Test live prey and influence of enrichment on wreckfish larvae, and broodstocks feeds on fecundity and spawning quality. Respecting larval husbandry, 2 tasks we proposed. One was develop a larval rearing protocol, and the other one was description the ontogeny of digestive system. At first, we know some about the wild wreckfish, because we have some broodstocks in captivity before the project, and we know the growth about 3 years ago, very important for start our work. Also, we know some about juvenile growth, and very important for the factor conversion, because the ingestion rate is low and factor conversion is very high. We study all about reproductive cycle, and we know the cycle of reproductive wreckfish along the year, since the vitellogenesis and the lipid coalescence and the maturation of oocyte until atresia oocytes and making out another time the maturation. Okay. And with 60 wild wreckfish from market, we collect the blisters, and we did the relation between ay Dios. Moment. Se me pasó aquí. Between the length and weight in wild wreckfish, yes. And we measure the biometric parameters, very important to know the species. For our work, we count with 4 broodstocks, 3 in Galicia, in the northwest, on the northwest of Spain. Sorry, excuse me. One in the Aquarium Finisterrae in A Coruña, in the north of Galicia. Another one in CMRR in the Ria de Arosa, and another one in the south of coast of Galicia, Instituto Español de Oceanografia, and another one in the HCMR in the Crete Island. We fixed 3 procedures to achieve spawns in wreckfish. The first one is a natural and spontaneous spawn, this one. The another one is, it could be hormonal implant, and the another one could be stripping of the natural males. Along this project, we can prove that the best system or method was natural and spontaneous spawns with difference. And along these years, we can prove the increase of the number of spontaneous spawns. Since 2015 to 2018, increased considerably, and decreased stripping, because stripping in wreckfish is very complicated for the large size, for the large tanks, and etc. We prove also the floating eggs and the fertilized eggs in the spawns, in natural spawns, spontaneous spawns, and increase also the fertility and the fecundity per female, that increase more than 160 60,000. Respect to the males covers the same period of females in maturation, reaching its peak in the months of April to June with these concentrations, 25 to 35 per 10 per 9 per milliliter. The mobility radio is high with mean values between 2 to 3 minutes. The mean survival time of the sperm conserved refrigerated at 4 degrees centigrade is 4 days. However, in some cases it reaches 18 days of survival. In summary, we can say that the spawning, respective reproduction, the spawning season covers the months of January to June and occurs sequentially in batches. The spawning takes place during the night or early in the morning, mainly between 5 and 8, with some exceptions that took place at midday. All greyfish broodstocks produce a large number of fertilized eggs and achieve satisfactory fertilization success. Also, spawning periodicity is 3 to 5 days, and fertilization success is between 50 and 100, with better quality eggs towards the mid or end of the spawning season for each female. Also, it has been found that one female is able to spawn an average of 10 times per breeding season. One male has the capability to fertilize at least 30 spawns in a period of 150 days during 5 months in 2018 at the broodstocks. And respecting the males, sperm exhibits a high percentage of motile cells activation and one of the highest initial speeds recorded for fish sperm. This high speed was associated with a long swimming duration compared to other marine fish. And the mean survival time of sperm maintained is at 4 degrees centigrade is 4 days. However, in some cases, sperm may reach 18 days of survival after collection. The spermatozoa concentration in greyfish strip sperm is of the same order of magnitude of that of brachy fish, such as European sea bass, gill-teeth sea bream of Migr, and it is higher than that sole and tabot. Males chasing the females, followed by the release of the gametes, and produce large volume of good quality sperm for a very long period of time, cover the same period of females, reaching maximum values in the months of April and June. The mean concentration of greyfish is 2.41 to 10, and spermatozoa in Galicia in January, while it remains around 1 per 10 to 10 from April to September, with no significant variation between sampling dates in Crete. Respecting to the nutrition tasks, we find that enrichment products for live prey, rotiferous and artemia, were developed with 2 levels of ARA, being the enrichment less effective in artemia than in rotifers. In this table, we can see the levels of ARA with the different enrichment products and the levels of proteins, lipids, and EPAs, and DHA, omega-6, omega-3. And larvae of greyfish present in general a good acceptance of enriched live prey tests. No difference in fatty acids composition were found. in larvae fed with the prey enriched with the two enrichment products were found. And fatty acid profile of fish larvae along the larval development was obtained, showing a big amount of PUFA, especially the HA and EPA and arachidonic. You can see in the graphic these levels, these high levels. Yes. Regarding the biochemical profile of fish muscle, the grayfish has a high amount of proteins and low lipids amount. And in this graphic, you can see the difference in levels of protein of biochemic profile in wild gonads and rare gonads. And these results are very important to formulate a specific dry food for grayfish broodstocks. Diet suited for grayfish were this type of dry food with this profile, and semi-moist diet in another stock, and squid in another stock. In summary, respecting nutrition, we can say that enrichment products for leaf prey were developed with two levels of arachidonic, being their enrichment less effective in Artemia than in rotifers. And grayfish larvae present in general good acceptance of enriched live prey test. The fatty acid profile of grayfish larvae along the larval development shows a big amount of PUFA, especially the HA and EPA arachidonico. And results obtained from tissues, composition of wild fish, and those obtained from eggs and larvae, newly hatched, were very useful to advance the knowledge of the nutritional requirements of this species, and for the formulation of the specific dry food for grayfish broodstocks. And the first results of larval culture are promising for grayfish, but it is necessary to continue with the research about nutritional requirements. Results obtained with dry food demonstrated that the grayfish diet must contain a big amount of proteins, low level of lipids, and a high amount of N3 PUFA, and the APR ratio must be similar to that obtained in wild female gonads. New diet was especially formulated. It was very important for the future of the future experiments with the growing grayfish. Respecting the larvae husbandry, the first trials the first results in HCMR and IEO was we take the first curve of growth and the first development of the larvae. You can see in these pictures some larvae deformed. That it was a problem also in grayfish. The curves of growth, larval growth with the lipid consumed in your sac, here in flow rate and here in RAS, and the curve of the grown with a temperature, with different temperatures, and the percent of the forms with temperature. With more temperature, the formed larva decrease, and it was demonstrated that in wreckfish, the deformant decrease with the temperature, with the high temperatures. We make also the growth curves in length and weight, with the equation potential in length and weight, and the curve of length in the IGAFA facilities until 65 days per hatching, post-hatching. Respecting to the ontogeny of the digestive system, doing by HCMR, the information about this is very important for the future also, and with a big period that endotrophic phase, according to the result from the histological analysis, material from the less heterotrophic sac was visible until 23 days. And in this slide, you can see the different cuts for the different days post-hatching, and the development of the different organs and structures. And respecting to the visual ability, the wreckfish larvae is identify rotifer in a radio of 7 millimeters, and 1.4 rotifers per milliliter, the minimum, okay? Regarding feeding sequence, we demonstrated that the better sequencing RAS system for the larvae culture is this. First of one rights rotifer since 8 to 19 days per hatching. Artemia naupli since 15 to 23 days per hatching, 23 days per hatching, and Artemia metanaupli since 18 to 48 days per hatching. After that, dry food since 40 days per hatching were administered with very good results until now, that the juvenile has 6 months of age. In summary, respecting larval husbandry, the optimal water temperature for artificial incubation of wreckfish eggs is a range of 60.5 to 19.5. Lower temperatures promote more deformity and lower hatching rates, with more eggs mortalities during the first 3 days of incubation. Temperature range between 16 and 18 may be adequate to improve survival and growth in wreckfish. Larvae were also characterized by the large size of the yolk sac, and the total absorption on the endogenous reserves lasts until 20 days post-hatching at 17 grades centigrade. The presence of the large yolk sac and the large oil droplet indicates that the presence of a long autotrophic larval stage. Some data about behavior were known during the project, like as a peak of mortality between 7 to 11 days post-hatching, herpes vesicles and deformity since 10 days post-hatching, eat voraciously since 6 days post-hatching, remain at the bottom of the tank and through the walls up to 10 days post-hatching, and they go up to surface between 7 to 14, where they remain the rest of the time. The larvae are able to consume food from the time that the mouth opens. Also, no exogenous feeding items were identified in the stomach contents. The coexistence of autotrophic and heterotrophic states for a long period during the first larval rearing period has to be taken in consideration for the development of new enrichment protocols for zooplanktonic prey that are used during the first stage. Optimal feeding sequence for the larval culture of grapefruit in RAS at 20.5 larvae per milliliter, and with a water temperature of 7 to 18 degrees centigrade, with desalinity and oxygen dissolved between this. And the rights rotated with arachidonic supplemented during this time, before that, sorry. And the study of the technical conditions at the adequate parameters regarding the deaeration, the flow and form of creating an adequate circulation of water, as well as continue investigating the larval malformations that occur in a high percentage are needs for the immediate future. Very important results were achieved in larval feeding sequence in RAS system culture. This data could be the starting point for the future experiments and a reality to propose the cultivation of grapefruit as a possibility of diversification of aquaculture. It is worth mentioning that in the GAFA facilities, there are 25 juveniles that reach 5 months that were cultured at approximately 18 degrees centigrade and represents a significant step forward in grapefruit larval culture and provides a basis for further studies. The perspective regarding grapefruit larval rearing are very encouraging, thinking about new useful species for the aquaculture, with very good perspective for the future. Our challenges has been achieved almost entirely, and we hope to continue working to consolidate the culture of the grapefruit. And the reasons to continue with grapefruit are the first results of larval culture are promising. Very important knowledge about biology, nutrition, reproduction, physiology, behavior in captivity, incubated and larval zootechnic knowledge adapted to the species and larval ontogeny. More studies of ontogenesis and the formation of the basic system of the rearing organism seems to be the basis on which the optimization of the protocol of grapefruit larval rearing should be carried out. Trials with ongoing captivity and cages and organoleptic conditions of farming grapefruit are necessary, and the scarcity nature is a reason to continue with the grapefruit. In the coming years, with the results obtained from the larval culture, with obtaining 25 juveniles of grapefruit, since the future they can help to increase the number of individuals in the different grapefruit broodstocks. In Galician coast, there are 3 companies dedicated with broodstocks of grapefruit, and it's very important to continue with this species for the industry, for the sector. And the future is farming, grapefruit, yes. Thanks for all, and thanks for all partners involved, CMR, MSC2, IEO, Las Palmas of Gran Canarias University, and at the HCMR of Greece, IFREMER, Las Palmas, ULL Tenerife, and EOLR of Israel. And now we can see a short video about our work. This is the broodstock of in the aquarium of Mr. Rai. Is Antonio the director? The Learning Center sampling. Sperm sampling and CASA system to qualify. This is value. In IGAFA facilities, here is a female and Tito's hands. And starting blood for analysis. These are mature females, spawning, spontaneous egg collection, and larvae in the bottom of the tank. Very active larvae. Alevins, juveniles, nowadays in the IGAFA facilities, eating dry food.
Thank you very much, Blanca. What is the size of these juveniles now after 150 days? Yeah.
The weight is 100.
100 grams.
The more, the higher.
The largest one.
The less weight is
50 to 100. Okay. 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 We have any questions? We have a few minutes before we go for lunch. Yes.
Thank you. I saw that your study focused on reproduction, yes, mainly, and I was wondering if you have any hints, any information of how the fish behave, the adults one in captivity, and if reproduction in the future becomes more efficient, how you see them growing? Do you see them growing in cages like sea bream and sea bass? Because it's a deep sea species, and I wonder how they behave in captivity, and this is my main question. Yes.
Yeah, the graphics is very
closer to your mouth.
Yes. The management of the graphics is very easy because it's adapted to the captivity very well, and I think that the future growing is possible better to make in cages, I think, because it's a large fish, and I think it's possible to that it could be the better system to grow, I think. Yeah, in captivity, yes, but no in cages. Yes, and in captivity, the greyfish grown 2 kilos in 1 year. Yeah, yes.
Can I add something to this? Because we have some early experience with the wreckfish when we did a study years ago with wild individuals, juveniles got from the wild, and we rear them up to to the broodstocks that we have today at the Institute. There is indeed no problem for the grow out of this fish. But there is an issue with the temperature, they cannot tolerate temperature above 21 degrees when the fish grow after 1 year. And this is the triggering when they migrate from the surface, where they have the juvenile stage, to the bottom of the ocean, of the sea, at the second year of their life. So either we go to areas like Galicia, where the temperature is perfect, or in the Mediterranean, we keep the fish for 1 year in captivity, and then we have to commercialize them. Now, this is not... Yeah, this is exactly what I wanted to say. This is not a big problem, because in 1 year, they can reach the Mediterranean 3 kilo, which is sufficient for a species to reach the market study. So this is the early work we did, I don't remember how many years ago.
Can I add something? Sorry. Sure. This is very useful information, but if I understood correctly, there's no evidence for growing in a cage. You have only in tanks.
Yes.
Yes, okay. So I see that in scientific terms, this is an exciting species. And you're really in a terra incognita and you collect information that's really exciting. But since funds are very limited, I wonder if for this species that you don't have any idea how it behaves in cages, because tanks are very different, are more controlled, if there is scope in investing, not in basic research, but if it's really a promising species. That's just, I'm not an expert at all, but just a naive question.
It's 4 million liters, and sorry. Well, I think you heard me.
Close.
Yeah.
I think
From
overall,
our
based on...
experience,
Yeah.
we have a big brood stock from since 1999, and they grow very fast. They are always together in the same tank, and they grow fast. And those are, our brood stock is the first one in reproduction, spontaneous reproduction, and they act very well. And it's different. The tank is completely different to the aquaculture tank. So they behave a little bit like the sea, no? Yeah, but the deep is 4 meters, so it's not too much. And then when we do the spontaneous, well, we check the wreckfish, and we see that they are going fat. So then we collect them from the big tank, and we manage to bring the mature females and the males to small tanks in order to have the spontaneous the spawnings.
The question, of course, is valid, because what you're asking is that, okay, you have just a little bit of experience with growing in tanks. Will it be the same or better or worse in cages? Obviously, we don't have this answer because we never had enough fish to do that. But based on the temperature that they grow the first year, how well they grow at the natural temperatures for the first year and a half, based on their behavior, which is a very docile fish. It's a friend of mine called it a fish with the highest petting index, because they really come to you and you can hand feed them. It's like little dogs, even more docile than groupers. So based on all this knowledge and knowledge that has been acquired earlier with growing wild fish, it should not present any significant problem, at least something that we see. For example, when we started growing shy drum, we pointed out from the beginning that this may be a problematic species because it tends to sit on the bottom. We don't see, at least my understanding is that we don't see any behavioral traits that will make us doubt the adaptability of the fish to cages. I think that's the belief.
Yeah, yes, but thinking...
But it hasn't been done. We never had enough. Based on the behavior of the fish and the growth and the response, it should not. It should not.
But thinking about the productivity for the companies, maybe the cages and for the density and for the production is a better system. I don't know.
Sorry. In fact, one of the most important companies placed in the north of our coast is working with black spot sea bream growing in sea cages, in a very big sea cages, and this company is very interested in that. Yes, in the Cantabric. Yes.
So another comment or question? Okay, so I guess this was the most challenging species from the beginning. When we put the proposal together, we knew that this was the most risky species because we knew the least, and it had to travel the furthest, and that's why its budget was also the smallest one. We'll talk a little bit in the afternoon about what are the challenges and what we think about going in the future, but at least we have addressed, I think, satisfactorily the issue of reproduction, which is the first issue, the first step. You have to have eggs to consider larval rearing. Larval rearing is still an issue, and it's for future research. And then once juveniles become available, as they have become available for amberjack during this project and for mallet, then we start thinking about growing it up. But it's a very good fish both for growth, from the growth data, the organoleptics of the fish, the market for it. It's a very rare fish, so we will never have issues with like cod issues that the wild products are so many that affect our price. They're so rare in the market. They're found throughout the world. They're appreciated throughout the world. So it is a good, theoretically a very good species.